Okay, we have problem 1. If f dash x is equal to 1 upon 2 sin x plus 3 cos x square, then fx is equal to. So here we have fx is equal to integral of 1 upon 2 sin x plus 3 cos x square dx, right? So this integral, if we divide by cos x both sides, that is say 1 upon cos square x and 2 sin x upon cos x plus 3 square. Okay. So dividing both numerator and denominator by cos square x, we will be getting this term. Again, this term is nothing but sec square x dx upon 2 tan x plus 3 square, right? So now substituting 2 tan x plus 3 as variable z, we have dz as sec square x dx. Okay, so now we can write the integral as integration of, in place of sec square x dx we can write dz, and in place of 2x plus 3 we can write z. So we have z to the power minus 2 dz. Now clearly this is based on formula integral x to the power n dx is x to the power n plus 1 upon n plus 1. So we have z to the power minus 2 plus 1 upon minus 2 plus 1 plus some constant, which is equal to minus 1 upon z plus, this is z to the power minus 1 and this is minus 1, so minus 1 upon z. So now transforming this to original variable, minus 1 upon 2 tan x plus 3. Okay, so minus 1 upon 2 tan x plus 3. Here we have done a mistake. The integration of dz can be written as 2 sec square dx. So this integration is basically 1 upon half. Right? So we have 1 by 2. Here also 1 by 2 is there. And so here also 1 by 2 is there. So from here you can see that option D is correct. Right? Now moving to second problem. The value of integral root under 1 upon root under x plus x root x is equal to. So we have to find the value of integral x plus root under x. If we take root x common in denominator, we will be getting 1 plus root x, right? So if we take root x is equal to t, then dt upon dx is 1 by 2 root x. So we have dt as dx upon 2 root x. So we can write our integral I as dx upon root x can be written as 2 dt upon root under 1 plus g. So this integral is clearly 1 plus d root under plus c is equal to 1 plus root x as per our substitution. So 1 plus root x plus c. So option B is correct here. Okay. Now moving to the third question. The integral cos x minus sin x upon root under 8 minus sin 2x dx is equal to. So we have the integral I is equal to cos x minus sin x upon root under 8 minus sin 2x dx. Here we will be doing some trigonometric evaluation and then substitution. So 8 minus sin 2x can be written as 8 minus 2 sin x cos x, which can be further written as 8 minus sin x plus cos x square minus sin square x plus cos square x, right? Which is further written as 9 minus sin x plus cos x square. So 8 minus sin 2x can be written as 9 minus sin x plus cos x whole square. So if we substitute t is equal to sin x plus cos x, so we will be getting dt is equal to sin x minus cos x dx, right? Now our integral will be becoming I is equal to, in place of sin x minus cos x dx, we can write sin x, the integral of sin x is this should be actually the integral of sin x is the differentiation of sin x is cos x and the differentiation of cos x is minus sin x. So this is dt is cos x minus sin x dx. So we have the integral I as cos x minus sin x dx, we can substitute it by dt upon, now root under 8 minus 2 sin 2x, we can write it as 9 minus t square. Okay, so this is basically the integral of form dx upon x square minus a square under root, right? We have seen that it is equal to log x plus root under x square minus a square plus, right? So this can be written as log here we are not going to use this formula because this is not based on this formula. This integral is based on dx upon a square minus x square, which is equal to sin inverse of x upon a, right? So we have dt upon n minus t square as sin inverse t upon 3 plus 3. So here t is sin x plus cos x. So I is sin inverse 1 by 3 times sin x plus cos x, right? Plus. So from option you see that option C is the correct one, right? Now moving to the next question. Here, if integration of log of x plus root under 1 plus x square upon root under 1 plus x square dx is something f of dx, which is a composition of two functions, then we have to find fx and gx. So we can write, let us evaluate the integral, which is log x plus root under 1 plus x square upon 1 plus x square dx. So here we substitute log x plus 1 plus x square is equal to t, right? So we have 1 upon x plus 1 plus x square into 1 plus 2x upon 2 1 plus x square dx is equal to dt, right? Differentiation of this with respect to x and differentiating this with respect to x, right? Okay, now from here we can have our integration as p dt, right, which is nothing but half d square plus t. So we have half log x plus root x square plus 1. Okay. T square, that means square of this number, plus c. So if we check the option from here, we can see that fx is equal to x square and gx is equal to 1 plus x square, right? So that f of gx is this number. So here we have f of gx as half log x plus x square plus 1 square, x square plus 1 whole square, right? So clearly from here we can say that fx is equal to x square upon 2 and gx is equal to x plus x square plus 1 root under, right? So we check, then we can say that option A is correct. Okay. Now moving to the next question. Dx upon x into x to the power n plus 1 is equal to, okay, we have integration dx upon x into x to the power n plus 1, right? If we take x to the power n as a common, so here it will be x to the power n plus 1 and 1 to the power 1 upon x to the power n. Okay. Now, if we substitute, p is equal to 1 plus 1 plus 1 upon x to the power n, then dt is equal to x to the power minus n, that is x to the power minus n plus 1 upon minus n plus 1. Okay. So we have dt, differentiating this with respect to x. Differentiation of 1 is 0 and then differentiation of x to the power minus n is minus n x to the power minus n minus 1, which is nothing but minus n upon x to the power n plus 1. So we can write into dx. So we can write dx upon x to the power n plus 1 as minus n dt. So now our integral will be transformed into minus n dt upon t, right? Integration of, which is equal to minus n ln t plus t. Now t is, we have substituted t as this number, so replacing with the original value, we will be getting n ln 1 plus 1 upon x to the power n, which is equal to minus n ln x to the power n plus 1 upon x to the power n. So plus some constant. So if we check the option x to the power n plus x, from here we can say that option B is correct. Okay. Now moving to the next question. If x square is greater than 1, then the value of dx upon t square plus 2xt plus 1 is. So we have to evaluate the integral. I is equal to dt upon t square plus 2xt plus 1. And it is given that x square is greater than 1. So this integral can be written in the form of t plus x square plus 1 minus x square. Right? We can write t square plus 2xt plus 1 as t plus x square and subtracted x square from that, because we have added x square here. Okay, so this is equally good as this above. Now again we can write it as t plus x, since x square is greater than 1, so we can write it as minus x square minus 1, so that this quantity becomes positive, right? So now from here we can actually take this integral is in the form of 1 upon x square minus a square dx upon x square minus a square. So its value will be 1 upon c. The value of integral dx upon x square minus a square is 1 upon 2a ln x minus a upon x plus a mod, right? So here in place of x we have t plus x, and in place of a we have x square minus 1, right? X square minus 1 root under square. So we can write this integral as 1 upon 2a. A is x square minus 1, okay? ln, that is log with base e, x minus a t plus x minus x square minus 1 upon x plus a, that is t plus x plus x square minus 1 plus some constant. So this is the value of integral. So if we see the options from here, we can say that option B is correct, right? So option B is correct. Now in place of these values it should be mod, right? There is mod actually in the question. So moving to the next question. If integral 1 upon e to the power x plus e to the power minus x dx is equal to a tan inverse e to the power 2x plus c, then the value of a is, okay, so this integral is given in the form of a tan inverse 2x, right? So we have to find the value of a. What is the value of that constant a? Okay, let us evaluate this integral dx upon e to the power x plus e to the power minus x, okay, which can be written as e to the power 2x upon 1 plus e to the power 2x square dx. Okay. So if we take e to the power 2x as t, then dt is definitely 2 into e to the power 2x times dx. Okay. So this can be written as, if we take e to the power minus x as common, say we are taking, then we can write e to the power x dx upon e to the power x 2x plus 1. Okay. So e to the power x as t, then dt will be e to the power x dx. So this integral can be written as dt upon t square plus 1. So we have tan inverse t plus t. Okay. Integral of x square plus a square, 1 upon a tan inverse x upon a. So the value of t is tan inverse e to the power x. plus c. So the value of a is 1 here. Here it should be instead of 2x, this should be x, and the value of a is 1. So option A is correct, right? Okay. Problem number 8. If I is equal to integral root of tan x plus root of cot x dx is equal to fx plus c, then fx is equal to. So basically we have to find the integral of root under tan x plus root under cot x dx, right? So first let us transform this. Write this tan x as sin x upon cos x and cot x as cos x upon sin x. So this tan x can be written as sin x upon cos x root under plus cot x can be written as cos x upon sin x root under. If we take sin x cos x as common, then we will be getting sin square x, sin x, root sin x into root sin x will be sin x plus root cos x into root cos x will be cos x dx, right? If we make this as sin 2x, then we have to multiply it by 2, right? So let us write in the form root 2 sin x plus cos x upon 2 sin x cos x dx. Now we will be substituting p as sin x minus cos x. Okay. So dt will be sin x plus cos x, differentiation of this into dx, right? Now we have the transform integral as root 2 dt upon 1 minus t square under root, because if t is sin x minus cos x, so we have t square as sin square x plus cos square x minus 2 sin x cos x. So this is nothing but this term will be 1 minus 2 sin x cos x. So we can write 2 sin x cos x as 1 minus t square. So we have transform integral like this, whose value is root 2 sin inverse t. Okay, so if we substitute the value of t, we will be getting plus some constant t, root 2 sin inverse sin x minus cos x plus t. Okay. We have evaluated the integral. Now we have to see which of the following are as same as our form. Okay. See, our integral, the value of our integral is root 2 sin inverse of sin x minus cos x. So this can be equally written as pi upon root 2 minus cos inverse of sin x minus cos x plus some another constant c1, because sin inverse x is nothing but pi by 2 minus cos inverse x. So this can be written like this. Okay. Also in form, if you want to write in form of tan inverse x, this can be equally written as root 2 tan inverse sin x minus cos x upon 1 minus sin x minus cos x square, right? So this is basically root 2 tan inverse sin x minus cos x upon 2 sin x cos x which can be equally written in the form root 2 tan inverse tan x minus 1 upon 2 tan x, root under 2 tan x. So all these three expressions are the expressions for our integral. So we have A, B and C. All these options are correct here, right? Because all these three are the same expressions only. They are represented in different forms. So if you find the value of an integral, then they can be of both integrals. And if the I am saying that if the value of integral, whatever you have found, if it is not matching with the answer and your both values, that is whatever given in the reference or you have found, are correct, then they are just transformed form. So you have to transform it. You have to check whether they are transformed form or not. Like here all these three are transformed form of each other. So we have all these three as integral of this, right? Okay. Now moving to the next question. We have the integral 1 upon x plus root under a square minus x square is equal to. So let us denote it by I. I is equal to dx upon x plus under root a square minus x square. Okay. So if we substitute x is equal to a sin theta, then we will be getting dx is equal to a cos theta d theta. Now dx is equal to a cos theta, so I will be, in place of dx I am writing a cos theta d theta. In place of x there is a sin theta, and in place of a square minus x square, so a square minus x square root under is a square minus a square sin square theta root under, which is equal to a cos theta, right? So we have a cos theta. Now a will be getting cancelled, so we have cos theta d theta upon sin theta plus cos theta integral. Okay, now this can be written as half of cos theta plus sin theta plus cos theta minus sin theta upon sin theta plus cos theta, right? So doing further evaluation, we will be getting half plus half of cos theta minus sin theta upon cos theta plus sin theta, half d theta. We are separating both the terms. So we have these two integrals. So the value of this is half theta, and here if we substitute cos theta minus sin theta, cos theta plus sin theta as t, then we will be getting cos theta minus sin theta as d theta as a dt. So here it will be, the integral will be half ln, substituting t is equal to sin theta plus cos theta. Your dt will be cos theta minus sin theta d theta. So this integral will be half ln mod of cos theta plus sin theta, right? So we have half, theta is sin inverse x upon a plus half ln cos theta we can write as, we have substituted a sin theta as x, so sin theta is x by a and cos theta is 1 minus x square upon a square root under, right? Minus plus x upon a plus some constant c. Okay. Further, if we remove this a constant, we have half sin inverse x upon a plus half ln a square minus x square under root plus x plus some another constant c1. Okay, and this half can also be eliminated by taking root under x plus a square minus x square plus c1. Okay, so from here if we see, then option C is correct, right? ln a plus a square minus x square half sin inverse x upon a plus ln a plus a square minus x square plus c. Oh no, this is we have found x is ln x plus a square minus a square. So note that here it is x. Here this is x, not a. So from here we have, if we see, if we try to check the options, which option is correct? So a is correct, right? A is correct. From a, if you check option A and B, then both have transformed form, right? Because sin inverse x upon a can be written as cos inverse a square minus x square upon a, isn't it? Because if we have sides of a triangle x and a, okay, then this side must be a square minus x square under root. So cos inverse x must be, theta must be a minus x square, this upon this. So this is equally good as this, and in place of some constant there is some ln a. So we have option B as also the correct option, because these both are actually the transformed form of each other. So A and B both are correct in this case. Okay. Now moving to the next question. Dx upon cos to the power 6x plus sin to the power 6x, sin x to the power 6 is equal to. So we have to evaluate this integral. So we have, let us name this integral as I. We have I is equal to integral of dx cos x to the power 6 plus sin x to the power 6. Okay. Let us divide this by cos x to the power 6. So we have, if we divide both sides, both numerator and denominator, by cos to the power 6x. So we have here sec x to the power 6 plus 1 plus tan x to the power 6. Yes, right? Okay. Sec to the power 6x can be written as sec 4x into sec square x dx, right? And here it is 1 plus tan 6x. Then sec 4x can also be rewritten as 1 plus sec square x whole square, sec square x whole square, that is 1 plus tan square x whole square, sec square x dx upon 1 plus tan 6x, right? Now if we substitute z is equal to tan x, then we will be getting dz as sec square x dx. So we have I as 1 plus z square whole square upon 1 plus z to the power 6, right, dz. Okay. If we expand this term, 1 plus z to the power 6, 1 plus z to the power 6 can be written as we have 1 plus z to the power 6 as 1 plus z cube whole square, or we can write it as 1 plus z square whole cube. So this can be written as 1 plus z square into 1 minus z to the power 1 minus ab z square plus z to the power 4, right? So this integral I can be written as 1 plus z square upon 1 plus z square z to the power 4 minus z square plus 1 dz. Okay. So this and this will be getting cancelled, and we are getting the integral 1 plus z square dz upon z to the power 4 minus z square plus 1. Okay. So now taking z square as a common from both numerator and denominator, we have 1 plus 1 by z square, and if we take common from denominator, then we have z square plus 1 upon z square minus 1, right, dz. So again, if we substitute z minus 1 by z as t, then we will be getting dt as 1 plus 1 upon z square. So we have this integral I now in t as dt upon this value z square plus 1 upon z square can be written in terms of t like z minus 1 upon z square plus 4 plus 2, right, plus 2. So this is nothing but t square plus 2, right. So this value is t square plus 2 minus 1, which is t square plus 1. So we have this integral as tan inverse of t plus some constant c. Now let us do the substitution further. Now doing back substitution, we have the value of t is tan inverse z minus 1 upon z plus c, and the value of z we have substituted as tan x. So we have the value tan inverse of tan x minus 1 upon tan x mod plus c. Okay. So this is nothing but tan inverse of tan x minus cot x plus c, which can be further written as tan inverse of minus 2 cot 2x plus c. So if you see from here, we are getting option C as well as option D, both are correct. Here also C and D are transformed form of each other. So option C and option D both are correct here. Okay. So this is the last question of this session. Thank you.